How are you?
I'm good. And you?
I'm great. I'm looking forward to meeting you today for a long time.
Me too. By the way, did you watch the movie I introduced?
Yes, I did. It was impressive from the beginning.
Hello everyone, my name is Tobias Rödiger and I'm from the TECO research group at the Karlsruhe Institute of Technology in Germany. In my demo, I will present a new on-skin user interface made from an innovative material called capillary silver PDMS. The key difference compared to previous work is that instead of just using binary silver and PDMS, it uses a secondary immiscible fluid that is introduced to the mixture. This creates additional capillary forces, which makes the entire system ultra stretchable. Due to these unique properties, we can tightly fit the sensors onto the user's arm. In our paper, we have built a resistive strain sensor that attaches onto the user's arm and can be used to provide a set of 6 distinct input gestures. By collecting a dataset from 10 participants, we have created a machine learning model that can classify between the 6 distinct gestures that we have defined. For example, this video shows how a user is swiping with its finger over a set of these strain sensors applied onto the forearm arm, which is detected by our measurement pipeline. We also performed an evaluation study where we were interested how the PDMS material feels to the user. Currently, due to the slinkiness of the PDMS cover layer of the sensors, it still does not feel tissue equivalent. However, this could be easily improved by adapting the surface texture. For future work, we hope to achieve higher spatial resolution and also envision to build a sleeve from the ultra-stretchable material in order for it to wrap around the user's forearm. I want to thank you all for watching my video, and I hope to see you at the next Augmented Humans conference.
Hello, I'm Frederick from the German Research Center for Artificial Intelligence. I'm presenting here an early prototype of a wearable for deep water blackout prevention. What is freediving? Freediving is a natural method of submersion performed during various activity in water. It relies only on the ability of the diver to hold his breath. The Divers Alert Network reported a total of 855 breath holds incidents between 2004 and 2016, of which 78% were fatal. Sieber et al. Proposed a system that reliably monitored the blood oxygen level for freedivers. The physiological data recorder used a combination of a 2-channel electrocardiogram with a pulse oximeter and a pressure sensor. The temperature and depth measurement was specified for up to 150 meters using a Lexan tube as a housing. This work provided the sensor hardware basis for our wearable. Our prototype monitors oxygen saturation underwater and conceptualizes an early warning system with regard to the diving depth. The predictive algorithm estimates the latest point of return in order to emerge with sufficient oxygen level to prevent a blackout. It currently notifies the diver with a sound. The basic elements of the warning algorithm can be described in these formulas. We have the influence of the water pressure and the average metabolic oxygen consumption. Also the metabolic oxygen consumption depending on the depth. We assume an ascent velocity of the recommended 9 meters per second. And in the end, we have our predicted oxygen saturation, which we simply calculate by a table lookup provided by Severinghaus, where we take the current oxygen saturation minus
Hello, my name is Yutaka Arakawa. I'd like to introduce the Augmented Workplace, human-sensor interaction for improving the work environment. As you know, work environment is very important, and sometimes that environment affects the productivity of the workers. Especially air quality and noise are important in the workplace. If the CO2 level exceeds some threshold, worker becomes sleepy. Maybe you have some experience. And also the comfortable temperature is different person by person. And sometimes loud conversation in open space prevent the others' concentration. So this is because I'd like to introduce the augmented workplace. It comes from the similar concept of Apple Watch. Apple Watch has the activity reminder, and the watch monitors the owner's physiological data by heart rate sensor or acceleration sensors and send a reminder by a message and vibration. As same as this concept, we set the sensor in the workplace and it monitors the environmental state such as the temperature, humidity, noise and light and CO2. Sometimes it sends a reminder by a message of Slack. So we implemented this system into our laboratory. I deployed the 20 sensor in the one room, and it monitors the CO2, humidity, noise and light, blah blah. And if the CO2 exceeds the 800 ppm, the CO2 sensor makes some action through the Slack, and the user change the behavior to open the door to improve their environment. That looks funny, but I believe it will be normal all the workplace. Thank you.